Hi, welcome to the next channel. So recently I shot a video episode on NAS OS, file system metadata overheads. So I discussed a few aspects of the same and also how it is going to affect the performance of your NAS system, and that includes even FreeNAS as well, because FreeNAS, as we know, it loads a lot of metadata of ZFS or ZFS volume into the RAM, and it does optimization because it has these things lined up in the RAM. Okay, let it be the cache or whatever it is, including the file system metadata as well as those ZFS blocks. As we know, these are usually typical data structures which are arranged in the fashion of a tree, because you will have folders and subfolders and subfolders within the subfolders, and also the files and stuff. The files are the end nodes versus the subfolders are like it is going to lead further down below the hierarchy. So it's a hierarchical data structure, and it is not a linear data structure, unlike linked list. So if you're an admin, I give a very quick overview. You have in programming called as arrays. These are fixed memory chunks. So each array is a similar sized elements. So it is a repeating element. So these things are allocated. The moment you load the program, okay, let it be even in kernel also. The moment the kernel boots, these arrays will get loaded, and it is a fixed static allocation. Okay, so when you think about linked list or these type of tree data structures, usually they are dynamically allocated memory space. So what happens is, as you create more directories, as you create more files, it generates the metadata. So the file system generates the metadata. As an example, if you explore the Linux kernel source, I know that being an admin, maybe you might not be well aware of programming, but I just want to give an insight so that you can understand the same. So if you explore the file system subsystem of Linux kernel, you can see it has various file systems, and it is going to miss the ZFS because it is released by Oracle in a different license. This thing actually, it is not released under GPL v2, so it is not coupled with the Linux kernel. But having said so, if you install Ubuntu server or something, you are going to get ZFS support in its kernel, because Ubuntu team, they are picking that ZFS stack, OpenZFS, which is released under CTDL versus GPL v2, and they are integrating and they are building the whole operating system or the distribution, which is still fine because it is not released as a part of standard kernel as a overall kernel release, and that's where it violates the license of that. So anyway, let's not get to that. So that is why you can't see the ZFS over here. But if you have Oracle, if you have Ubuntu server or something, and if you download the Linux kernel source through Ubuntu server, the current working kernel source, then you can find ZFS in the main kernel folder, not in the FS folder. You should able to find it in the main folder. Okay, so that way, if you go to the file system and if you explore any file system, let it be ext4 or FAT or NTFS, whatever it is, you can go here, and if you explore some of these folders, you can get various APIs to do this traversing stuff and all that stuff. You just imagine all these things are preloaded into the memory, and this is why FreeNAS team or the IX system recommends you to have an ECC RAM or something. But in general, you should have ECC RAM in any computer device, let it be even a smartphone or let it be even a PC or a laptop. So the ECC RAM, to an extent, it gives you that utmost guarantee that whatever is loaded into the memory, it is not going to be corrupted. So you just imagine all these data structures are going to exist in the memory, which is nothing but RAM, and if something gets corrupt, and it is going to be corrupting the file system over there, and it is going to reflect in the storage drives as well. It is not so significant in a case like this versus in something like ZFS. It is going to treat whatever it is in the memory says is the ultimate, and if anything gets from the disks, it is not going to trust that information. So if anything is changed randomly, arbitrarily in the memory or the RAM, and it is going to sync this data, wrong data, corrupted data, innocently on the drive as well, and further corrupting that file system. So this is why they recommend. But again, in some extent, if you are in expert level, if you are using certain situations, still it is fine. Even in non-ECC memory, it's not going to cause any harm. But having said, you should always be careful to have multiple backups of the same, so that in case if your ZFS pool or something gets corrupt or something happens, you will have a mirror copies elsewhere, so that you can restore your backups. So that's quite important. Even I have an entire mirror of my NAS on my hard drive, so it is still fine. Or once my other NAS is ready, I can even do an Rsync, and then I get the actual copy of this entire content. So that's what. So you can go through such APIs where it has different APIs to traverse across this the file system metadata. And whenever you attempt any read write operation, see, when you do this way, see, this is my mounted NAS in through SMB or Windows protocol. Okay, so you can see here, this is my local drive, you can see here, and if I go here, do anything, it is getting from that metadata. Okay, currently it is loaded on the local system as a part of mounting that Windows share, okay, of this FreeNAS, and it is showing in my local system. So local system have mounted, and then it has got this metadata refreshed. So whenever I go here, do anything, it is going to sort of pull that stuff, that hierarchy of the directories, whatever, it is going to have an local instance updated with this kernel source, and then it is going to show whatever the content. So you can see here, for instance, this is my very old Acer laptop. I have some backups, and trust me, this should contain millions of files and stuff. So what I have done is, you can see here, some I have just archived into a single file, and once I extract the same, okay, this is around 8.7 GB versus 2012, this is around 4.5 GB versus this 2010, you can see here it has multiple files. So each one have thousands and thousands of files within the same, and also many folders, okay, hundreds or thousands of folders. So when you compress the same, it has to load in that file system metadata just one entry. Just imagine that. Okay, so this is what puts a overhead. And when you do, especially, this is something I missed in the previous episode, is when you do any Rsyncs or something like that, when you do that housekeeping tasks, it will be incredibly fast and snippy, rather than having it dispersed around. And when you do anything, it's going to be slow, and it is going to take a lot of time to sync this metadata and then do file operations after that. So you need to be aware of that file system metadata always is going to be overhead. These days we don't see this issue in modern laptops or the smartphones, because they are having a very good computational power, as well as they have enough RAM to deal this stuff. But this is a significant performance variable when you think about computers which have been around 1980s and 1990s, because at that point of time there is some amount of significant overhead because of this type of excessive metadata. Okay, but these days it is scoped up with modern computer power and modern computer hardware. Okay, so that's what, or else the server, whatever. Okay, so that's what each one, if you kind of even see this, say for instance I took this 2009 and from this, and I thought let me just do some maintenance. I delete some obsolete ones. I'm not bothered about 9.4 GB. It has so much of obsolete content. I thought at this point of time I can do some amount of maintenance of this data. It has both very vital data as well as trivial, not so important data. So I need to figure it out which is not needed. I just want to delete and do some amount of housekeeping of that. Okay, so that's what. So that way, if I extract, it is going to extract more and more files, and once I extract that, it is going to completely extract all that discrete stuff within each of that tarball. Okay, so that's the thing. So when you represent this into something like this, see, this is what happens. Okay, so when you think about the metadata, this is what happens. See, as I said, a linear data structure is going to be more like this. Okay, you are going to have similar typed elements like this in an array, and it will be allocated in the beginning. Okay, so if it is done in the kernel, the time the kernel boots, it is going to allocate that memory space, and it is going to exist forever. If it is in a kernel module, of course you can delete, and by the time you do module exit or something, you can of course free that to an extent. But what happens is it will be allocated in the beginning. Otherwise, you have the other model, which is the linear linked lists. Okay, something like this. Sometimes it will be connected by a single link. Sometimes it will be connected by multiple, links. So this is like a forward connecting linked list. Sometimes, if required, you can even connect it this way. So you can call this as a doubly linked list, something like this. So this is one more data structures. But when you think about a file system, you can see here always a file system is like a hierarchy. It's like a tree data structure. So which is why when you think about file system, this is not going to work. This is easy to manage to an extent, and you need far less amount of APIs, and it is easy to traverse and go back and delete any node and then adjust that list. But here is where it becomes cumbersome. Instead of these two data structures, let me just move this out of this way, and let me represent a tree data structure. See, if you think about a tree data structure, you may have some hierarchies. This can be a subdirectory or subfolder or whatever under this directory, and after that you may have some files beneath that. Okay, in this folder you may have hundreds of files, and it is going to represent that in that metadata. Okay, so it may have this hierarchy. It should have that data, it should have that reference that each of this file belong to this particular subfolder. And when you do any cut, copy, paste or any such operations, when you move this file from this directory to this directory, then it has to adjust that metadata. Of course, this is what exactly it puts that overhead in the system. So you can imagine this itself is kind of cumbersome to represent. You just imagine in the real world scenario, you have a laptop with hundreds of files and hundreds of folders, or else thousands of files organized within hundreds and hundreds of folders. So this is the sort of overhead it creates, and this is more amplified in a large storage system like this NAS servers. And that includes even FreeNAS as well. So make sure if you are an admin, you practice some type of an methodology so that these things are optimized. And for instance, I can show you that I have some Rsync scripts I can run right away because I have done some few changes. Let me go here and do the Rsync. I have done some changes in this backup folder. You can see here, this is the folder which is mounted. It's the backup share. So I can do this Rsync, and you will see, whatever I have done, it is going to delete some local copy, update with the remote copy, and it is going to do something. So you can see the performance when I do the same. I have shot a couple of episodes on this Rsync part, but I did a mistake about adding the Z option in that Rsync, which means compress when you do the Rsync. I suggest you check with compression and without compression, whichever is much faster, you can pick the same. Okay, so this way if I do that, I can test its performance here. We keep an eye over here so that we can measure also the transfer rates. Okay, so let me provide the password. Yep, so it's just going to start, and when you monitor here, you see the transfer rates. It's around 880 megabits per second, which is quite decent enough, as you can see, for a network of 1 gigabit Ethernet connectivity. Okay, so you can see here. So this is what essentially happens. Okay, this performance is also going to go down when you have excessive metadata overheads. It has to first sync this metadata, and then it has to do the transfers, and even those transfer it's not going to be bulky enough. It may be small files, it may be something which is few kbs. For that it has to initiate each time a TCP connection, and it has to do this hundreds of times. Let's imagine you have some Linux kernel source which is not compressed and you have put across in the NAS or something like that. So this is what is going to add that overhead. Okay, so you can see here how fast it is happening, and also the transfer rate is optimized. Okay, the rsync is optimized. So this is what it is. So this way you can assess your performance of your overall NAS installation, and optimize for that metadata. You just see that wherever there are excessive amount of files put together, try to just tar them once in a while, so that it is not increasing this metadata. Okay, so once this happens, I can also show one more last example, and then I can wrap up this episode. Okay, yep, it's almost about to complete. You can see here some it has deleted, which is no longer there, and some it has been copying and things like that. This is happening in my local system from that remote NAS. So it is happening from here to here, it is doing that sync. Okay, so once it is over, it is done, and we can take another example which you will understand quite shortly. Okay, well, as you can see, it is still doing the same. It is still about to complete, because this is around 17 GB is what it is. So yeah, you can see it is going to just complete. Yeah, it's over, and to confirm you can try running the same once again, and this time nothing should happen effectively, because it's just done this rsync already. So you can see here it's over. I can show one example. See here, here if I go to this Toffee project and I go to the website, you can see here this is the website contents. I keep some amount of historical backups, so that I can traverse across in case if I need something in the past. Okay, so this is nothing but this website backup. So whatever is in the Toffee project, or else the Linux channel website data. So this effectively, this entire stuff is what is this backup is. Okay, so that's what it is, and you should able to see the current website is 11.x. Okay, this is around 122 megabytes. So this is what it is. So each time when I do some changes periodically, weekly once or 10 days once, I'll take a backup. Okay, so you can see here this is what. And if I jump across inside the archive folder, so you can see once in a while what I do is I just do a tarball of that all those files together. So it is not large, you can see it is just 4.1 GB. So effectively we have made a single file out of some 50 or 60 files. Okay, so depending on that file sizes. Okay, so this may have around 50 or 45 files, and this may have around 50 or 60 files, and things like that. So much older backups contains more quantity of files, but recent backups, since currently it's around 100 megabytes, to get something of 3.1 GB, see this 10.x is around 3.1 GB. So to get something like that, you can manage with less quantity of files. Okay, so that's what. So now effectively we have transformed around 500 to 600 files into just 5 files. So you just imagine that metadata overhead here. Okay, so this is what takes time, and often I see that YouTubers when they discuss about NAS operating systems, these are all enthusiast builders. They may get an expensive server build, but they are not any systems developers or something. They are enthusiast PC users, or they may have some gaming setup, or they may have some YouTube channel, and then they may have some backups. They may often discuss about this Plex media server and stuff. But the thing is, what happens is, when you think about the internals, this is what is going to affect the performance. Sometimes it is so mandatory that they have to upgrade to some SSD or something, because the way they manage their files, because they don't manage it in a right way, they may have also several project files which they just leave as it is. So effectively they are going to end up having thousands of files for every couple of projects or something like that, versus an optimized system like this. So this is what, so you can see here it is done, and currently the running version is 11.x. I have deleted much older ones, so I don't have anything before this 6. So 1 to 5 is deleted recently, and the current running version is 11.x. So the moment I reach around 50 to 60 files and it is around 4 GB or something like that, what I do is I download it in my local system, I do a tarball, and then I upload over there. Sometimes there is a disadvantage with the same. Sometimes if this tarball happens to be corrupt, you are going to lose all the files. So you need to be very careful whenever you do this operation, just to know that what you are doing. Okay, so in case if any of this single file gets corrupt, it is still fine, but just imagine this tarball gets corrupt, then it is going to wipe out all that 50 or 60 files. So it is quite a risky move, but still with the modern computers we can anyway do quite easily, and you can also check whether it is reliable. You can open it and see that it opens and stuff. Okay, so things like that you can do as a part of your optimization of your storage servers. Okay, so that's what. So metadata is very, very important when it comes to performance, and when you do any mirroring, NAS mirroring or Rsync, it is going to affect the performance, and it is going to bump up that performance, or else it is going to request each file what is the status, and it is updated in the local system. It's going to ignore that file, and it is going to switch to the next entity, and it is going to check if there is any local system not updated versus in the NAS it has a different copy. Then it has to delete this one and it has to sync it with that updated one, and it has to do this over and over again for thousands of files. But you can see here in my case I have done some few changes. You just see here it's just transferred very few files. Of course each file is quite large, but it is going to be optimized with your good network connectivity. It's just going to create one TCP session and then it is going to transfer that, versus you just imagine having hundreds of files or millions of files. It is going to do that many TCP connections, and it has to, I mean, of course not all together at once, but one after another, and it has to transfer these things in any such transactions. So I hope this video have given you enough insight, and if you are struck with any performance issues and you want to investigate especially the systems aspects of the same. Okay, see, I'm not just an enthusiast builder or something. I'm a systems developer, and I can investigate in the systems aspect what could be the reason or something like that. So if you have such issues, and if you also have some type of data corruption or something, if you find it quite challenging, feel free to ping me, and I will try my best in terms of addressing your needs. As I say, I can even go through the ZFS or ZFS stack, and then I can see that if there is any solution around. And especially often you find an issue with optimization. You may have an excellent server hardware, but still you may struck with some performance bottlenecks. In my case, I just built with a regular end user consumer hardware, not any server platform. Especially in India, we don't have this eBay culture, and you don't get any used hardware at a good price. Sometimes they put quite hilarious pricing. I mean, they may put some old stuff and they may quote like anything actually. So you don't have any proper eBay culture here, but so it is better to buy a new hardware which is trusted, and also it is going to come at a fairly reasonable price, rather than venturing around any kind of special hardware or any kind of server components. Especially it is very expensive here in India. Generally any IT equipment is quite expensive than US. It is 30% expensive over here. Let it be video cameras or any PC components or laptops, whatever it is going to cost around 30% more than any other most other countries. So we have to think these aspects quite seriously. So we need to come up a way that how to optimize the system first, rather than just dumping a very good hardware and then not optimizing your system. So think about it quite seriously. Your metadata is of course going to be serious, and the more you have these hierarchies and files, the more it has to occupy in the RAM the moment it loads, and then it is going to stay over there, and it is also going to eat up some amount of your ZIL, ZFS, intent log and other components. So naturally the caching, whether it is write caching, read caching, I'm not telling that you have put an SSD or without SSD, even in case you have not added any cache drives, read write cache drives, still it is going to do in the main memory itself. So it is again going to get affected because of this metadata, because this is going to occupy some significant chunks of space, and it is an added overhead. Okay, any operation you do, it has to do this stuff, and it's an added overhead before it starts any file transfers. Okay, so anything you do, before it does even any file transfer, it has to read this metadata, it has to find where these 1000 files are there, and then it has to decide what to be done, and it should be cached, it should be pulled to the main memory from the drives, rotating drives, and then it has to serve these files one after another. So this is what is the overhead. So think about it, and it's a very serious overhead. Optimize your NAS server. If you have anything to discuss, be in touch via mail or post your queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.